Welcome to STEM NOLA. My name is Dr. Calvin Mackey, and I'm happy to have you all tuning in. As a little background, we founded STEM NOLA 7 years ago to expose and inspire and engage communities in science, technology, engineering, and mathematics. In the last 7 years, we've engaged over 50,000 K-12 students, over 12,000 families, and over 1,500 college students and STEM professionals. One thing that I'm proud to say is that we've put over $1 million in the hands of college students over the last 7 years serving as college interns with STEM NOLA, going out and engaging the community. So thank you for tuning in. Parents, thank you for believing in STEM NOLA and trusting us with your most prized possession, your child, your scholar. STEM NOLA believe that either we're training ourselves from the neck up or the neck down. In the 21st century, our children will only have one or three options. Either they're gonna take something, break something, and/or make something. And if we don't give them the skills and education to make something, like make a living, make a life, make a difference, it only leaves them with the two options that we see on the news every night, and that's to take and break. I don't want that for my two children, and I know you don't want that for yours, and that's why we're here today to expose our children to the possibilities of the 21st century. This is my friend. This is Alpha. Alpha is a humanoid. A humanoid is a robot that tries to act like a human. This humanoid has 9 servos and can do pretty much anything physically that a human can do. This is our competitor in the 21st century. Alpha can actually do push-ups. Alpha can even show off. And Alpha can even dance. And like any superhero, Alpha has her own music. This is the machine. And the automatic machine in the 21st century will displace many workers. In the aftermath of COVID, you have to believe that there are many companies out there saying never again will we allow a pandemic or something that happened in nature shut us down. So COVID has exacerbated the possibilities of machines displacing people. If you're competing against Alpha, you will not win. The only way we defeat Alpha is by developing our heart and developing our head, training ourselves from the neck up such that we can control the robots so that the robots will not control us. That's why we're here. That's why STEM NOLA exists. That's why your parents want to make sure that you all participate in events like this so you can know the possibilities of the 21st century. Again, I'm Dr. Calvin Mackey, and I want to say thank you for tuning in. Now let's get busy innovating, creating, and making with STEM NOLA. Thank you.
Thank you so much, Mr. Mackey. Next up, we have Damon Singleton, the meteorologist for WDSU News Channel 6.
Hey everybody, I'm Damon Singleton. I am a New Orleanian here in New Orleans, Louisiana. I'm enjoying a pretty warm day out here, but you know, as warm as it is, it's not as hot as we've seen it over the past couple of months, that's for sure. I'm a meteorologist. I work at WDSU TV here in New Orleans, Louisiana. And, you know, I'm from here in New Orleans. I'm a graduate of St. Augustine High School here in New Orleans. You know, when I was going to college, I was looking for a school that was, you know, close to home, that offered a major in meteorology. And I went through my college catalog at the time, because, you know, you got to, you know, back then you pulled out a college catalog and looked through it. And I found the University of St. Thomas in Houston, Texas. And I applied, I got accepted. I graduated from high school. I went to the University of St. Thomas, and I entered my, my course of study in meteorology. And, you know, for some people, it's a 5-year program. For some people, it's a 4-year program. I spent 4 years studying meteorology. I was going through the Navy ROTC program at Rice University, also in Houston, Texas. And so when I graduated with my degree in meteorology, I was commissioned as United States Naval Officer. And so I'm a retired naval officer, and I am also a meteorologist, currently a meteorologist at WDSU TV in New Orleans. I tell you, when I was a kid, one day I was, you know, I grew up in an area called Academy Park, a subdivision called Academy Park here in New Orleans, and Academy Park is made of two streets. One of those is LaFawn, the other one is Chantilly. And the park where all the swings were and the basketball court and everything else like that, the park was on Chantilly, and I lived on LaFawn. So one day, I was walking down the streets with some of my friends. We were going to the park to play basketball. We got to the corner. The park was a block away. We looked at the park, and it was raining on the park, but it wasn't raining on us. And my friends all threw their hands up in the air and went home. And I stood there going, wow, 1 block away from me, it is pouring rain, and it's not raining on me. And I stood there until, of course, it started raining on me too. And from that moment to this moment, I've been fascinated with the weather. I've been fascinated with the atmosphere. I've been amazed at how things work, and how it's all kind of connected together, and the forces at work that keeps it all moving around the globe, 24 hours a day, 7 days a week. And weather does that. I mean, it never stops. It never ends. Everything is kind of connected. And while things are moving in one direction in the northern hemisphere, they're moving in the opposite direction in the southern hemisphere. And when you look, in fact, take a look behind me here. You see those clouds up there? That's some cumulus clouds in the background. I hope you can see that. Some cumulus clouds in the background there. So the weather here is pretty good, but all those clouds that you see up there, a lot of folks don't know that's just water. That's ice crystals. And it starts down here on the surface as just warm, humid air. And as it rises through the atmosphere, it goes through different levels that are colder and colder and colder. And so the vapor in the warm, humid air changes state to a vapor you can see, from invisible to visible. And it's just amazing for me anyway, when I think about it, and that's just a small part of what I do and what I experience every day. But when you think about that, used to be right here on the ground, now it's in the air and I can see it and it's a cloud. I just think it's pretty cool. So my fascination with weather and meteorology and the atmosphere, started when I was 14 years old with a thunderstorm that was a block away from me, and it's become something that I do every day, and it's an enjoyment for me. And because it's something that I enjoy doing, it's not work. It's just a good time to kind of figure things out every day and give that information to the public, and have people thank me usually for providing them with information that they need to work, to play, to take their families on vacations, to do all kinds of things that everybody does, because everybody is affected by the weather. Everybody is affected by the weather. I hope you are as fascinated with this topic as I am, as I have been all my life. Even as a United States naval officer, my time spent there wasn't directly as a meteorologist, but a lot of what I did as a surface warfare officer was impacted by the weather. And everywhere I went, people counted on me to provide them with information that they otherwise wouldn't have had without the knowledge that I had as a result of my education and my degree. And so this has been a fascinating ride for me.
Thank you so much, Mr. Singleton. So we're just going to run through our agenda before we get. Oh, sorry. My name is Jalen Carr. I'm from New Orleans, Louisiana, and I'm a student at Boston University. Now we're going to get into the agenda. So the first thing on our catalog, we're going to go through vocabulary terms, and then we're going to hit the objectives. I'm going to ask y'all an activity question that we'll revisit back at the end, and then we're going to get into our activities. So for today, we have water cycle in a bag, warm and cold fronts, and then like I said, I'm going to go back to your questions. And finally, question and answer. So first up, vocabulary. So front. A front is a boundary separating air masses of several characteristics such as air density, wind, and humidity. Air mass is a body of air with horizontally uniform temperature, humidity, and pressure. Precipitation is just rain, snow, sleet, or hail that falls down to the ground. Evaporation is the process of a liquid changing into a gas. You're going to need to remember these for our activities. Our objectives for today. You will understand the meaning of the terms front, air mass, precipitation, and evaporation, and then apply them to the project correctly. And you will learn how to make warm and cold fronts, hopefully. So our question of the day, like I said, I'm going to revisit this at the end, so just keep it in the back of your mind, maybe write it down or take a picture, because we are going to revisit this. What happens when two air masses meet and form a front? Does warm air rise or sink? And finally, how do evaporation and precipitation work together? So our first activity is water cycle in a bag. So for this activity, you are going to need a Ziploc bag or a plastic bottle with a cap. We're going to use a Ziploc bag for our demonstration. Hot water. Ask your parent if you need help getting some. You can just stick it in the microwave for about 30 seconds. Blue food coloring and markers. While y'all gather your materials, I'm just going to run through the science behind it. So the water cycle describes how water evaporates from the surface of the earth, rises into the atmosphere, cools and condenses into rain or snow in the clouds, and falls again to the surface as precipitation. Those are some of our vocab words. The cycling of water in and out of the atmosphere is a significant aspect of weather patterns on Earth. So I'm just going to get into the experiment. Hopefully everyone has their materials. Can you do a... Okay, so first we're just going to draw out our water cycle. I'll go into more detail once it's drawn. So we have evaporation. And remember, that's rising. Evaporation is rising. So we're just going to draw some arrows up. And then we're going to have our sun. You don't have to be an artist. I'm definitely not. Just do your best. And then we have condensation, which is our clouds. We have precipitation, which is, again, our rain, sleet, hail, etc. And then we have some mountains, trees. Make sure to hold your bag securely. And this right here is surface flow. Gonna draw some happy little trees. And then your sea, of course, your body of water is at the bottom. Alrighty, so just to recap, the water cycle is just a continuous movement of water throughout the atmosphere. Evaporation, which is your first cycle, so essentially the heat from evaporation, the heat from the sun causes the water from the sea to evaporate, and this forms clouds. Next, we go to your clouds. Once the water cools, as Damon Singleton said, the higher and higher you go, it gets colder and colder. As the water cools, it forms condensation, and this is essentially the process of gas turning into a liquid. And then precipitation, you have essentially water vapors, the water vapors condense, And as they get heavier and heavier, eventually they fall, and that's precipitation. And then surface flow, it falls onto the ground, off of mountains, etc. So for this demonstration, we are going to take some warm water. Can you do the front view? We're going to pour some more water into a cup. And this warm water will act as seawater. And we're going to watch as this water goes through all of the cycles. I'm going to dye it blue just because the sea is blue. And we're going to pour it into our bag. You're just going to want to pour about a cup of water. It doesn't have to be exact. You don't have to measure it. Just enough to cover the bottom. And we're going to seal it, and we will revisit this activity at the end once it's completed all of the cycles. I'm just going to place it to the side. So now we're going to move on to our second activity. And we're actually going to create a front. This has to be my favorite experiment. So the materials that you're going to need red food coloring, blue food coloring, a strip of cardboard, a clear container, hot water, and cold water. Again, you're going to want to heat your hot water in the microwave for about 30 seconds. Please don't hesitate to ask a parent. It is going to be hot. Don't get in trouble because of me. Okay, so we're going to take our clear container. Oh, I'm so sorry. I'm moving way too fast. My mind is racing. So while you gather your materials, I'm going to read the science behind it. So a front is a boundary between two air masses, resulting in stormy weather. A front is usually a line of separation between warm and cold air masses. When the warm air mass meets a cold air mass, the warm air rises since it's lighter. Remember those thought questions I asked in the beginning. As it rises, the warm air cools rapidly. This configuration, called a cold front, gives rise to cumulonimbus clouds, often associated with heavy precipitation and storms. The weather science experiment can also be used to model ocean currents. They behave similarly, and it's neat to see how temperature alone is enough to keep water separate. Now we're going to start. So you're going to take your clear container, and you're just going to want to get a rough estimate of how big it is. We're going to cut a line straight down the middle. You need to get the diameter of your box. Mine is about this big, so I'm going to cut it there. Take your time, ask for help with these scissors. It is kind of difficult to cut cardboard. It doesn't have to be perfect, just big enough to fit in there like this. That's perfect. So you're just going to want to create a barrier between both sides. And then our second step, we're going to get our water. We have cold water. Feel free to put ice if your water is not ice cold. We're going to pour our hot water. I have a beaker, but I'm assuming that you're getting yours from the microwave. Alrighty, and we're just gonna dye our water. Let's see. I just want you to pay attention to the dye as it goes into the cup. So this is, I have red for our hot water, and just look at how quickly the dye dissolves into that water. Isn't that beautiful? It's a very fast process as compared to the cold water. I'm just gonna give it a stir. You don't have to watch it the whole time. And then our cold water, you'll see the difference. Look how slowly it dissolves. Still hasn't moved. That's so cool. I love that. Just gonna stir it up. Make sure to put the top firmly on. And then we have our, oh, right, a recap. So I have dyed the water. We have hot water, we have cold water, and we're going to mix it in here to see what a front looks like. Alrighty. Let's move this so you can see it. So I'm gonna pour both of these at the same time, and I want you to take notice to what it looks like. You can make your own observations and then we'll go over it. Can you switch? Alrighty. Count of three. 1, 2, 3. So just watch. So I'm going to quickly take this out, and I want you to notice that as the water rises, as it cools down, the hot water, the red, as you see, is going to rise to the top. And the blue is going to settle at the bottom, and then in the middle, we're going to have some purple. It just takes a moment to do. I think a top angle shows it better. I just think it's so cool how you can still see the separation. It's not instantaneous. Just give it a moment. So the food coloring moved faster while this happens. The food coloring moved faster in the warm water because the molecules are farther apart. All right, you can kind of see it now. So the ring at the top is your hot water. Hot water rises. And then at the bottom, you can kind of faintly see it. You have your blue, and then in the middle, we have purple where it mixed. And that's that. All right, so that is our second experiment. Just move everything off to the side. What? Ah. And then we're going to go back and revisit our first experiment. And you can see all of this condensation, all of the cloudy stuff, that's condensation. And if you can see, they're water droplets. They're large water droplets falling. That's your precipitation. Can you see it? I'm going to lay it down. All right, this is the best I can do without ruining it. Okay, so the cloudy stuff up here, this is your condensation. These are your clouds. And then the droplets falling down, as it condensates, it cools and it forms large droplets. And that is called precipitation. That's your rain. Your rain is running off of your mountains, your trees, your large buildings, and that's called surface flow or runoff. And then it goes back into puddles, it goes into lakes, it goes to the sea, and the process starts over. So we're going to go back to the questions of the day. I gave you all some hints throughout, but we're going to go back. So our first question, and on the screen, a poll should pop up, is what happens when two air masses meet and form a front? A, warm air rises, B, cold air melts, or C, warm air makes rain. Oh, wow. Everyone put warm air rises. That's great. That is correct. Our second question, does warm air rise or sink? The options are A, rise, B, sink, or C, neither. This one isn't that hard since we just did that. Alrighty, let's take a look at your answers. Everybody got that one right. I am so proud. I would have been upset if you got that one wrong. And then our last question, how do evaporation and precipitation work together? This one you might need to think about. So we have A, without evaporation, you can't have precipitation. B, they don't work together. Or C, evaporation doesn't work at all. Let's think about that one. Please make me proud. Can get the Jeopardy music playing. Most of y'all got it right. So the correct answer is A, without evaporation, you can't have precipitation. And just to go back over what evaporation is the heat from the sun evaporating. Evaporating is turning from a liquid state to a gas state, the ocean water, the surface water, and evaporating that into the sky. And precipitation is rain, sleet, slate, hail, etc., snow. Does anyone have any questions? If not, you can email any pictures that you may have taken to webinar@stemnola.com and come and join us for our environmental science presentation on October 14th at 4 p.m. Central Time. Bye, y'all.